Hey there. Previously, we created the block class. Chained together, these block instances will be the individual units of a larger blockchain. Now, before we jump forward to a new feature though, let's take this opportunity to adopt a test-driven development approach to this project. So test-driven development is an approach to programming where indeed, well, you test everything. But the extra catch is that you write the tests first. So the practice goes like this. You write some tests. Then you get those tests to fail. So make sure those tests are red. Then you write the code to get those tests to pass one by one. You keep going until all the tests are passing and green. Once all the tests have passed, it's time to move on to the next feature by writing a new set of tests. Now, if it's your first time with test-driven development, this may seem like a really odd and backwards way to code. It's true that the style does take a little getting used to, but there are three main reasons why test-driven development will benefit us greatly, and it's a perfect approach in developing this blockchain project. The first reason is that this will give us a lot of confidence that our code works reliably. As we add new features, we can be sure that old code still functions properly as long as the tests pass. The second reason, test-driven development will actually speed up the coding process, believe it or not. Without test-driven development, you need to run the entire application to test any new feature that you add. You might end up having to go through more functionality than you need to only test out and experiment with a new feature that you added. However, test-driven development allows you to hone in on one specific piece of the code by focusing on the test or tests for that new content. And the third reason, and the most important one, is that test-driven development will give you, as the student, an opportunity to apply your knowledge and the concepts you learn without always seeing the actual code and logic first. Meaning once the tests are written down, the implementation can completely be up to you. As long as you get the test to pass, you can be sure that your code supports the relevant feature in the blockchain system. So anytime you want to take up a learning opportunity and a challenge, go ahead and pause the lecture once the tests are written, and then try and implement the actual logic yourself. There'll always be an answer later on, so be rest assured that you can watch the coding logic to get the test to pass. With that in mind, let's consider how we would have developed the block class with test-driven development. First up, back in the block.js file, let's remove all this experimentation code, so we'll get rid of block1 as well as the console.log. And then go ahead and comment out everything within the class block itself. So make sure the constructor is actually commented out. I highlighted and then I use command/ to automatically comment out all those lines. Before we move on to the test, we will add one new line though. At the end of the file, let's add code to make sure this class is shareable with other files. So we do that with module.exports equals block, which is the Node.js sharing code syntax between files. Cool. Now let's suppose we originally developed this class with test-driven development, which starts by making a block.test.js file. So notice that the file name is almost exactly the same, except it has this extra .test extension before .js. Cool. I'll make this full screen as well. Next, we'll set up an overall test using a keyword of the Jest library called describe. So we call describe. And then usually the very top is the name of the block class that we're actually testing. So in that case, it is capital B block. So that's the first argument to the describe function, the name for the actual group of tests. The second argument to describe is a JavaScript function that it can run. So this is going to be a callback function. We create a callback with our arrow function syntax, parentheses, equals then sign, greater than sign, and then a pair of curly braces. In this describe block, we can then set up a few variables and then write tests around those variables. So we're going to set up some variables for the following tests. First, let's declare a variable for every relevant field for a block. So we're going to have a timestamp constant. Likewise, we want a last hash constant. We want the hash constant, the data constant, as well as the overall block itself in another constant. And then we'll assign values to each constant. So the timestamp let's have a dummy value. So let's have a string that says a date. The last hash, well, we can make that anything. So how about foo hash? The hash itself can also be anything. Bar hash is a nice dummy value. Again, we're following this trend of making dummy values. So for data, how about an array of a string that says blockchain and another string of data? And then finally, the block is going to be a block that consists of all of these fields. So we'll make a new block whose timestamp is that timestamp variable, whose last hash is that last hash variable. And this trend is going to continue. So the hash is the hash and the data is that data field. Now notice that all of these key values are the same for the block. In JavaScript, if the key and the value are the same in an object, we can use a shorter syntax, which essentially makes it so that you only have to specify these fields once. So you only have to write timestamp once, and then last hash once, and then hash once. And the great thing about this is that these keys are automatically used, and the value is whatever the value is stored as in the local variable for that actual keyword. Cool. So this sets up all the variables in our group of tests within this describe block. Now let's write our first test. For this first test, we'll write one that ensures that every block has all the properties we just went over: the timestamp, the last hash, the hash, and the data. And to create a test, we use the it function. It is very similar to the describe function. It takes a string message as the first argument. And as the second argument, it takes a callback function to run. For this message, let's say that a block has a timestamp, a last hash, hash, and data property. So this will be our first test. It's enforcing that all these properties exist on the block. And then we have our callback as the second parameter to the it function. And notice that we're wording our message in a way such that it reads nicely with the it function name. It has ... So it's nicely oriented so that this testing file is very readable. Within the it function, in order to run a test, well, we provide an expect statement. So the expect function takes one argument, a value to test the value upon. So this is the actual value. So the actual value is a block.timestamp. And we want this to match something. And to match something, we use a toEqual function. So we'll expect the block.timestamp to equal the timestamp variable that we originally declared. So this is the expected value within toEqual, and then the actual value is the block.timestamp, which goes within the expect function itself. Nice. We can do the same for the last hash, hash, and data. So I'm going to copy and paste this line 3 times. I'll use Command D to edit both of these. So that way I get block.lastHash is equal to last hash, block.hash is equal to hash, and block.data is equal to data. So make sure you have all of those expect statements. Now it's worth mentioning that having more than one expect statement in the it function isn't a best practice. It's usually best to have one expect per it function. However, once we get more practice with test-driven development, we can worry about maintaining proper coding conventions. The focus right now is to give test-driven development a spin. So this completes the overall block.test.js file. Now let's get to actually running the tests. Previously, we installed Jest as a development dependency in the project. So Jest is going to run this test on our behalf. To fire Jest, let's add a new script, or rather edit the existing script within the package.json file of the project. So in the local package.json file, notice that there is a default test command specified. And instead of this echo business and exit business, let's call Jest. We'll also provide a watch all argument to Jest. Overall, this will tell Jest to run any files that have that .test.js extension. Cool. So once you have that, head back to the command line. And what we want to run is npm run test right within the command line. All right, and as we do so, it's going to run that block.test.js file. And what we have is red output, a fail overall on our new block.test.js file. But this is actually a good thing in test-driven development. It points out things that we need to write in order to get this test to pass. Now, the first thing it's doing is it's saying is block is not defined, and that's actually an error in our block.test.js file. We need to require this block class at the top. So let's make a constant of block, and this is the syntax for requiring code within Node.js. We use the require keyword, and then when we point to the file where the code is located, and then we set that export to a local variable. So this will make the block class that was exported in the block.js file available in this test. And notice that we don't have to specify .js. .js is implicitly specified by Node itself. As we save this, back in the test now, it should rerun. And this time, we still have a failing test, but the error is different. This time, the first test failed. We're expecting the value to equal a date, but instead we received undefined. And now the goal is through test-driven development to get these tests to pass one at a time. So on the left, I'll have the testing file, and on the right, I'll have the code. And what we want to do is bring back this constructor. So I'll uncomment this out, just the constructor line first. So overall, the constructor will have the timestamp, the last hash, the hash, and the data. And the first thing that it's missing is the timestamp. So I'll uncomment that, and I'll set it back in. And now we get a second new error, and this time it's the foo hash, which is that last hash value that it's expecting. So if we uncomment that, well, again, the error is different now, and this time it's the hash. And finally, we get the data portion. And with all of that, we're all green, and the block class is now complete. Pretty epic, huh? In all honesty, it was probably a little underwhelming for all the cloud task-driven development gets from experienced programmers. But really, that's all there is to the approach. You write the tests first, you see red filling tests, then you get to do the fun stuff and get the actual code in to get the test to pass and find a green suite again. Right now, the benefits of test-driven development might not be super obvious, but that's because test-driven development comes most in handy as a project grows and becomes large. So as our blockchain project continues to develop, test-driven development would become an extremely helpful programming style. All right, see you in the next one.